Thank you, everyone, for coming today. We're so excited to have you for our second AI literacy event featuring Professor Carsten Lange from economics. He's going to be talking about generative AI, a beginner's guide. And we're going to do some interactive activities and demos where we see how this stuff works in real time. So this is the second AI literacy event that we've hosted from the Digital Humanities Consortium this semester. By the way, I forgot to introduce myself. I'm Alex Madva, co-director of the Digital Humanities Consortium, along with Dr. Rachel Van, who's joining us from Zoomsville this morning. We are super excited to have you. So the Digital Humanities Consortium is an interdisciplinary group of faculty, staff, and students who are looking at the intersection of the humanities and digital life. So using digital tools to engage in humanistic projects, asking philosophical and historical and literary questions about the digital world. And so one of the central things we're trying to do is improve literacy around AI. So our first event was held a couple months ago by Professor Dana Marshall from COM. You can find a recording of that event on our YouTube channel. And if you, in general, if you'd like to stay up to date with all of our cool DHC activities, on your tables there is a QR code for following us on Instagram. We're also going to be dropping information about that in the chat. Without further ado, please join me in welcoming Dr. Carsten Lange.
Thank you. Welcome. If you like to follow along or if you like to see the slides later on, you can see here there's a link that you can use. I'm trying something here. I want to give you a little bit technical background about large language models because I think it is important. We can only talk about and use something where we basically know how it works. I hope I don't do it too technically. I hope I do it technically enough. You tell me later then where I'm standing. So I said it already, you need to understand it for effective use. And obviously also when we talk about problems, we need how to work it. We just want to go on a clickbait where somebody has a sensational story where somebody dropped dead by using AI. So I think understanding the background of AI is similar than if we imagine we time travel with the TV to the year 1885. Electricity was already invented, movies were not invented. People will be excited. And naturally they will think there are little tiny artificial people in a box and they stage a play for us, which we know is not true. Then it will not take long. Then they will ask the question, what if these people come out there or the bullets just by accident fly at us? They are afraid. They see dangers. They don't see the more relevant danger that people watch too much TV. They focus on the little bullets. But then when we know that the TV screen, and we all know that now, they wouldn't know that the TV screen is not even a picture. It's just like a number of pixels and our brain processes the picture. They don't have to be afraid of the bullets anymore because they know there are no little people in it and they can focus on the real problem. And that's what I'm hoping to accomplish here with this talk. So the outcomes, I will show you how generative AI fits in the picture of AI. We will talk about how to code tokenize English words. I will introduce, at least try, the basics of a neural network. We will talk about the word order. Dog bites child is obviously slightly different than child bites dog. And then we have to talk about attention. That was the biggest advancement that was recently made. And you can see that here. The cat sits on the mat because it is soft. What is soft? The mat or the cat? Well, we know it from the context that it is a mat, but the AI, the large language model, has to learn that, and that was a big leap forward a few years ago. We will talk about fine-tuning a neural network to specialize it and to get rid of discrimination and racism. And we will have a few demos. That's a fun part, and I hope they work. Okay, we start here. The big circle is AI. It includes way more than ChatGPT. AI is defined as everything where we believed only humans can do it and now machines can do it. In an extreme case, you can go 30 years back and say an elevator that closes its door automatically could be AI, because people would say, how does the elevator know that there's nobody in the way? Now AI includes self-driving cars, and I learned it recently. Self-driving cars are mostly rule-based. They don't learn the data. They don't let a car drive over and over on a course and then it learns how to drive. It's rule-based. They would say, if you see a shadow on the right-hand side, go to the left-hand side. If it's not rule-based, if it's data-based, if you take data and try to induct something, that's called machine learning. Machine learning is a simple regression that you learn in statistics. It could be a random forest model, it could be a neural network model. And if it is a neural network model, and if that is big enough, we are here in deep learning. And then when the neural network model deals with language, this is where ChatGPT comes in. This little part is ChatGPT. This little part is generative AI, and not the big thing. AI is way more than ChatGPT. Okay, here's a little bit of the history. I don't go through every detail. Just, it started in 2003 with a very basic way to learn language. The first successful model was actually here, but it would process the language word by word by word. So every word was fit one by one through the huge neural network, and that was incredibly small. The breakthrough 2017, attention is all you need from a Google team, and that is able to process a whole prompt. A prompt is just a collection of words. And meanwhile, I did the similar talk in my class about 1.5 years ago, and I said, an AI has 32,000 words. A prompt has 32,000 words. Well, we are at 1 million now. That is an equivalent of 10 novels, and they are all processed at the same time. That makes them so incredibly fast. So our problem is computers can process numbers, and we need to process numbers. You will see AI is no miracle. There are only numbers behind it, so we have to do something like 3.2 times dog is 0.1 times cat. If I subtract that, what's the result? So how do we do that? The thought that comes probably first is, well, why don't we use it how computers do it already? They code our letters into numbers. The letter S is coded as 83, and here's a binary number for it. The bad thing with that is this is not how our language works. If I talk to you, I'm not working with letters. I don't piece letters together, get the word, and so on. I start at the word level. I form words, the word forms sentences, the sentences form a talk. The only reason that I need letters if I want to write it down. So we cannot start with letters. That would be way too complicated. We have to code words. And this is our first topic. How do we code words? We have to answer 2 questions. Which word is worth coding by itself? And which word should be coded as a subword? Unattractive. Maybe we don't want to code unattractive at one word. Maybe we code it as attractive and combine it with un. So I have a few examples here, and I will show you how ChatGPT does it. Untrained horses eat apples, but apples do not eat untrained horses. And then another one is here. DHC is incredible. Good, let's get the D2. Okay, here are the decisions to make. Which words do we want to code? And if you go later on, probably you can go here to the footnote, and you go directly to OpenAI, and I can copy and paste here my first sentence. And what you see is un gets its own token, trade, horses eat apples, comma gets one. And there is also a token that we will need later on that means end of sequence. That basically means shut up, we're done. So another thing I want to show you here, how's this one coded? You see, the D is worth getting its own token. The H naught and the C naught, they are often enough showing up together. They get their own token. And you can see in this case, unimaginable is coded as one word. It's done by an AI program that runs before we even start. So how do we code now? We have about 200,000 words, and I simplify here. We don't have subwords just for the matter of speaking. And I simply sort them alphabetically. They're differently sorted, but it really doesn't make any difference. So how do we do this? I code two words here, the word neural and the word network. This is a list of 200,000 words. Each word here in a vector, that's our coding, has an entry. And that entry can be either 0 for apples, because neural is not apple, neural is not zoo either, but neural is neural, it gets a 1. We do the same with network, a list of 200,000 entries. Network is not neural, there is a 0, but network is network, it gets a 1. So we have like lists or vectors of 200,000 lengths, and that's quite wasteful, but that is how we start. Okay, that allows that, and I admit this is really absolutely ridiculous, simple example. And no language model works like that. But with this, we can already do something very simple, to guess the next word. We want to type in neural, and the system should guess network. How do we do that? Each of these nodes has a number here. Here the 1 goes in, here the 0 goes in, and so on and so on. What we want a list like this that says network. So these numbers here, they get processed and led to the next node, and not only to the next node, to every other node. And on the way to the other node, they get either weakened or amplified. These are our parameters. And then that happens here and here and here again, and I end up with 200,000 numbers. That shows me the probability of the word, and it didn't work here, right? We want network, but that has only a probability of 0.03. And why would it work? Because I took a random process to initialize that. But neural networks have a mechanism where I can, every turn, adjust each of these weights to make the error a little bit smaller, and I can measure the error. This is supposed to be a 0, but it's a 0.001. This is supposed to be a 1, and it's a 0.003. So I can measure the error. Every round, the weights, the parameters are adjusted a tiny little bit until I get a better result. So I run it, my neural network, and after a while it's done. And now I have something like this. And you can see the highest probability is here 94%. So the neural network would choose network. Feed in neural, get out network. I can do that only with pairs of words. It's very simple, but I think it shows you the idea of a neural network. I can feed something in, and I can require something as an output, a numerical output, and after some training, it will generate that output. So why is that not great? Well, first of all, this one-hot encoding is incredibly wasteful. I mean, I have these vectors, almost 200,000 zeros, and just 1, 1. There's no semantic in there. Neural network, they belong together. They should be similar coded. They're not. There are no positions in there, and there is no attention in there. We will get all of this now. We will first get the semantics in. And before I do that, I want to show you where we want to go. What I want to do, and that is actually how large language models work. I feed into the prompt, what is the tallest mountain? Goes in here, comes out. What is the tallest mountain? It just guesses the next word. I feed that in, comes out. What is the tallest mountain? The tallest mountain. Goes on, adds the is, adds the mount, adds the Everest. And what I also should say at the end, it adds the end of sequence token. That's a signal, okay, I'm done. I don't keep talking anymore. That's what we want. Our system can't do that. The one I showed you can only have one word generate the next word. Also, I want semantics, and that's up to you here. If I take king minus male plus female, what do I get? Queen, correct. With king, I take away the gender, I add a different gender, and then the king without the male gender but plus the female gender makes a queen. And we want a coding that can ensure that. That's important. And great should be similar than amazing, tomatoes similar than apples. I think you get the idea. So we also want to go down from 200,000 to about 512. That's easier to digest. So here's an idea. We hire, and it's ridiculous, but bear with me. We hire a linguist and say, hey, take our 200,000 words and sort them in 512 categories. The linguist might say, okay, my first category is noun, apple, tomato, king, queen, man, and woman are a noun, amazing and zero is not. We can have another one, negative and positive, apple, tomato, somewhere in the middle. Amazing is something that is a 1. Great is almost as big as amazing. King and queen have something positive, and a man and woman is somehow neutral. And you can see the sex here. That's important because this is what we need for our calculation. You can see here our king is coded as -1, so is a man. If I subtract this, I'm at 0. If I add female, I'm at the queen. So it would work. Problem is, our linguist would take forever. So what we do, we push that to a neural network, and the neural network does exactly what the linguist does. Except it doesn't tell us the categories. So think about a stubborn linguist. When he or she is done with the work, it says, well, here are the categories. And I ask which is which. It says, I don't tell you. But the words are correctly coded. That's all you asked me for. That's how you can see that. How is it done? And this, now it's good that we know how a neural network works. I feed very small sentences. In this case, only 3 words. But later on, I will show you an example where we feed Twitter feeds in it. And I feed these short sentences as a prompt into the neural network. And the weights are randomized, so garbage in, garbage out. But over time, they get better and better, and the neural network learns what it is supposed to learn. In this case, all these tweets have the word apples in it. It learns apples, which is ridiculous. You would say, why do I want that? We don't care about what it learns. What we care about is all of these are 0, except apple is always 1, and the other one are sometimes 1. Let's focus on the apples. The apples is always 1, and apples are here. So here we feed in a 1. All the others feed in mostly zeros. If I multiply 0 with something, it really doesn't matter. So all these other ones don't matter. But apple matters here. And then we have these weights here. And these weights are the ones I use for the encoding. And I have 512 because this layer here is 512. And big surprise, that's often like, it somehow makes sense. But the big surprise that we often get in AI, something makes somehow sense, but it just works great. The good people from Google, they provide us free servers. And let me see if it's still alive. It is. So they spin up a Unix machine for me. And here is how the word computer is coded. In this case, not with 512 numbers, only with 128. I can execute this here. It codes it again. That is executed on the Unix machine that is somewhere, who knows, in Iceland or so. And now, all my words are coded. It's 512 list of categories. So what I would expect, and this is Twitter feeds, what I would expect that the word Vladimir is similar than Putin. And if I execute that, I get the same result than here, 0.78. If I execute the word Putin and chemist, I get a negative 0.7. Putin is not a chemist. Nobody used that in context. If I try something else, if I take male, female, that should be in there. And you can see, hopefully, 0.58. Don't draw the conclusion and say Vladimir and Putin is closer than female and male. It just means they appear very often together. That is word encoding. Our words are encoded in 512 entries, each word, and they have meaning. Okay, now the problem is we feed in these 1 million tokens at the same time of the network. And you might ask, well, if I just ask how high is Mount Everest, well, then a few tokens are fed in and the rest is simply blank. So we don't overuse it. But if you talked in one chat with your ChatGPT, it does not only feed your question in, it also feeds in your previous question and possibly the output of that. That's why it makes sense to delete something. If you do research about a programming language and now you want to do research about literature, it's probably a good idea to delete it and then start from scratch. So we need a position to that. And that is actually a fascinating topic. It just takes a little bit longer. I can give you here, if you click here, you can read an article how they did it. I will just show you the result. Child bit dog. Dog bit child, what is it? They are all fed in at the same time. The poor neural network, our poor large language model has no idea. So after I do the positioning, after I store the position with it, I have something like this. Dog is the first word, bit is the second word, and child is the third word. And the way that is stored is not as 1, 2, and 3. It is stored as again as a vector. So you can think about like a secret code to store 1, 2, or 3. That's a secret code for the 2. I simply add that to my embedded word. I get a new list that has the encoding in it, and that's good enough that the neural network remembers the coding, which is really, I read it over and over and over again because I didn't believe it. I said, that can't be, you just add it and that's good enough. It works. So we have the order perceived now. And now comes the big thing. The animal didn't cross the road because it was too tired. The animal didn't cross the street because it was too wide. In the first case, it points to animal. We say it pays specific attention to the word animal. In the second, the same word, pays attention to street. Our large language model has to learn that. And I don't show you, that is actually the part that is most difficult to understand, so I just skip it. It would take a while to cover it. So I just show it to you. Here we go. Here's a result with the graph. I don't want you to focus on the process, just on the result. We're only talking about it. The word it. I have to do that for every word in the sentence. We just forget about all the other words. The large language model would not, but we do to keep it simple. We only focus on the word it. The word it takes 0 attention to the word the. It takes a lot of attention, 0.7, 70%, to the word animal. Then a lot of zeros. Street gets at least 5%. That's not surprising because it is a little bit ambiguous. And it takes attention to itself. That's included for technical reasons. And for tired, 20% for whatever reasons. We would not always understand these encodings. So now I know that. And then what it will do is it creates from all the word, for each word, weighted average for all the other words, adds it all together. For each word, I get a new list of 512 words. But this new list includes, in the case of it includes added 70% of animal. So I have another word, and now our list of 520, of 512, includes meaning includes attention. And it gets better. And I promise I don't cover it technically, but I want to show it to you. I don't do that only once. I split my original word, my it, with 512 numbers, into chunks of 64. You would say, why would I do that? Remember, these are the categories originally, right? So now in the first chunk, I have the first 64 categories. In the second, the next 64 categories. And then I do the attention for each of these categories, which is called different attention heads. Big word. I just repeat what I showed you 4 times. And the advantage is now the attention focuses on different aspects. Often aspects we don't even understand afterwards. So this is a large language model, again from Google. It's not mine, but they opened their code and spun up a Unix machine for me. And I can check these codes here. I pick layer 1. That is from a translation model from English to German. I don't want that. I just want to see the English coding. So I stick here. And these are the different attention heads. I switch them all off, except the second one, because that one is the easiest that I can interpret. And it's exactly my example. The animal crosses the road. And if I now go to the word it, was too wide. It focuses more on the word animal than it focuses on the word street. So we can actually see it. Some of these things don't make sense because it's a machine who did it. So, but it works. Again, and that's where I really want to get your attention on. We are doing numbers here. This is statistics. This is numbers, not anymore. It works great because that's why it's not any less, but it does not work because our system has awareness. It just processes numbers. So please get away from that. We think there are the little people in the TV who might shoot at us. Neural network does not have awareness. A neural network, a large language model, can't do reasoning in the narrow sense. It can produce results that are very close to reasoning. And they explain stuff, and it's good enough for us. Under the hood, it just processes number. So we have attention, and now our neural network is ready to produce something. So we're done. Our neural network is trained over weeks and weeks and weeks with almost the whole internet. Well, on the internet, we find a lot of garbage. We find a lot, not a lot, a little compared to the whole internet, but we find racism there. And we don't want our neural network to do that. Also, the internet is knowledge-wise extremely broad. But maybe I am a lawyer and I need a legal system. The internet is not good enough for that. So now I fine-tune. And with the fine-tuning, I can get rid of racism if I do it smartly. And people made a lot of progress. From the times when all the 4 people in the monument were black because they just overdid it technically, that is history. They are so good in doing it. And they are so good in fine-tuning, good enough that you can produce computer code with it, and it actually works most of the times. How do we do that? There are many procedures you can use. I list them here. I only cover supervised learning. It is commonly used, but it's definitely not the only one. And from supervised learning, I only cover transfer learning. So I have my nice neural network here, and it learned all its parameters. And now what I'm doing is I freeze almost all the parameters, saying, well, when you continue learning, you're not allowed to change these ones. But some I leave open, usually the last 2 layers. And now I retrain it with, for example, my legal thing. And this is how neural networks get fine-tuned. Now I have something that's not just babbling around about the internet. I have something that can help me with legal cases. I can see the history of legal cases because this is what I have fed in. And the system can only be good if the lawyers who wants it provide me with good data, because the system can't learn anything that it doesn't see. As a hint here, it's in the slide, I followed this course here from Super Data Science. It's a 4-hour course. If you take a trial, it's free. It took me about 2 weeks. It took so long because I would watch something and I would have to go back. I would watch some of these videos 6, 7, 8 times until I really got them. And I was already at the end and I would say, no, I need to watch the first one again. That's what I recommend you to do. If you want to learn about AI, watch videos. Watch them again and again. And if you don't get it after you watch them 3 times, find one on a lower level. Then come back to the higher. Just don't give up learning. Now, we have a demo here. And hopefully my ChatGPT is still open. So you know that large language models have a certain language. They are fine-tuned to be polite. Right? When I ask my son knows better to program than I. When I ask him for advice, he would say, I told you already 3 times. How could you not remember? I say, I'm sorry. Well, large language models don't do that. They say, oh, you're very close, you're so smart, and whatever, which is nice. We don't want a large language model that insults us. But if I write an email, if I invite a friend for a barbecue, I don't want this bold language. So what I found on a podcast, and I want to show it to you. Where is it, my human writer? It's called a human writer. And what it does, whatever I prompt in there, invite my friend to a party or whatever, before that prompt, it puts a huge bunch of text. And somebody did all this work and said, avoid this grammatical phase. I don't even understand it. That's like, probably was a linguist who did it. So at the consequence, it works better. And let me see if I can get it for you. I edited, that's a GPT. I can add this stuff. Thanks to the people of INIT to make that available for us. That was a big question. I recently talked to the leadership of INIT and they asked, how are you using AI? Is it worth it? And the answer, yes, it's worth it. Yes, it's worth it. Yeah, you can use some free version, but these GPTs, you cannot use. Can you survive without them? Sure you can. But you want to learn how to use them. So it's super important that they do that, and that's a good thing. So now I would hope, oh yeah, here's configure. And here are the instructions. You are a human writer, blah, blah, blah. And then comes all this text. See, avoid. I hope this helps, blah, blah, blah. Ultimate, the answer depends on all these phrases that should be avoided. And it helps. Invite my friend to a formal dinner. I'm brave here. I never tried this. Surprisingly, it's slow. My friends, I hope you're well. I'm hosting a formal dinner on blah, blah, blah. This is a very down-to-earth formal invitation. It's not like, I would be blessed if you could join my dinner or whatever. So this is a technique, and I don't show you because this specifically is so cool. This is a technique that I can use to improve a large language model. I want to show you something that you can use yourself, because there is one bad thing here. I cannot make my GPT public. I can invite people, or if you're interested in using it, you can drop me an email, and I invite you individually, and you can use it, but I cannot say it's public to everybody. So I did something here for my AI book. I thought, I write an AI book, I better have an application for it. So I have this one here, Ask AI, and I use Google for it. That's why you can use it, and the GPTs you can't use. And I can ask here, what is a neural network? And I can ask way more detailed, but I just do this one here. This one actually I did test. So, I have to push the search button. So what was done here is, in the code, in the prompt, like in the human writer, I put the summary for each chapter of my book. And then it searches on the internet, but it considers the summary. So, what is the neural network that comes from here? But look here, deep learning, MLP, this is where it's covered in the book. So imagine you have a publisher and they do that for all of their books. You go to the publisher's website, they pull that from the database, throw it in the prompt, and they don't only answer your question, they would say, on a low level, I recommend this book, on the middle level, I recommend this book. I recommended it to my publisher, they were interested. Companies work so slow. There are so many administrative obstacles, but eventually we will see it. And eventually is not in 3 years. Eventually is in 1 or 2 years. So, 2 more. And this is unfortunately something I can't make available for you. I use that for my course. So I have a link in my machine learning course. My students can go there. I had about 20 students, so I just added them one by one to this GPT so they can use it. And it's here, machine learning course experience. And what I did in this case, I uploaded my complete book. At that time, I was thinking, well, maybe that's a little bit too much. A book, it's about like 100,000 words or so. Well, now it's a joke. It's a 1 million. Of course, I can upload my whole book. I uploaded it as a PDF file. I also uploaded my syllabus, and I gave instructions that it should distinguish between content questions that would be answered through my book and the internet, and course-related questions. So I can ask, explain k-nearest neighbors. It's a machine learning thing which is used by Netflix to give you recommendation, nearest neighbors. And an S. It's kind of forgiving. I would still recommend when you do use prompts, make sure you don't have spelling. You don't want to make it more difficult than necessary. So here comes the explaining, and then according to practical machine learning, blah, 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 basic concept, how it works, and it would show you, hopefully, yeah, I can't scroll, scaling and normalization. That is stuff that is sometimes taken from my book. Sometimes it's enriched with the internet. When you build your GPT, you can actually block the internet and you can say, I don't want that. But this is such a big topic, I didn't want to do that. So it has everything. Here's chapter 4. So I have a course question. How can I be successful? And now it knows, it focuses more on my syllabus. Attend all classes, blah, blah, blah. Use the R model. I use the specific tool, tidy models. That must have come from the book. And usually, here we go. There are 2 midterms where 30 and 35%. That comes from the syllabus. That's a super powerful tool. And then in the last 10 minutes, especially for the instructors among us, I will ruin your day. It truly ruined my day. And I was thinking if I should do it. I seriously was thinking if I should do it or not. It's a cheating tool. It's a cheating tool from Google. And if that would be a secret, I would say I don't want to spread this secret. But that is so open. I think everybody younger than 30 in this room knows it, and everybody older than 30 in this room doesn't know it. So what I did, I created a quiz system. This has nothing to do with AI. It's a general quiz system for my students. They get questions. Everybody gets the same question, but they get different numbers, and the quizzes are automatically graded. I programmed that a while ago, 2 or 3 years ago, and now it entirely runs in a browser. In here with my username, Lang. And this has nothing to do with AI. So I'm a student now, and I'm working on my first thing, and then I think I have to right click, I forgot it. Search with Google Lens. I click on it. And instead that I have to do something, it offers already to me. Solve question 1. And it's a perfect solution. So to all the instructors in this room, what do we do? This is something, new AI is notoriously bad in calculations. That's a weakness. Imagine how easy it is if it says, write an essay or answer an essay question. I think if I give the students a homework, and I could say, well, maybe they're on the higher ground, but maybe they're also busy. Also, this one guarantees them probably about 90%. If they do it themselves, they might get 80% or even less. So what do we do? And since INIT is here, we had at one time, we had a lockdown browser. And during COVID, the university decided that that one was too expensive. I was very surprised about that. We need this back. That does not solve the problem that people can cheat at home, but at least in the classroom they can't cheat. And as instructors, we have to think further. We have to say, how can students do homework? I would think maybe we need huge testing centers where students can drop in, all the computers are locked, and yes, I cannot do all of my homework through that testing center if everybody would do that, but if we have like a few hundred computers there, and it could be cheap computers. We don't need much from these computers. Maybe that's a solution. Maybe if we think along this line, we find better solution than I can come up with within 10 minutes. But we have to do something. And now I can open it up for discussion.